Awesome. Hi, everyone. This is Manisha Naku. I'll introduce myself. I'm Manisha from ThoughtWorks, data engineer. I've been working with Ankur on a data project, and what we're going to talk about today is our shared learning experience on doing data transformation using DBT, the testing aspects, and so on. So looking forward to this. Ankur, over to you.
I'm Ankur Chen. Have some around 6 years of experience doing manual and automation testing. Uh, Comparatively new to data, but I've worked on some data testing. Let's go ahead with the session.
All right. Let's get started. Before understanding what data models is, let's understand data pipeline, right? I assume all of you would have heard this term data pipeline, right? What is data pipeline? If you take an example of how today's event is going, right, we are relying on the feedback that you're giving us, right? So let's see if we were to analyze how this event happened and was it a success and so on, right? There are some parameters that we'll have to look at. Now, in this process, right, how does data pipeline help us? Say we want to see how many attendees were part of the session and what was the duration of session, the kind of talk, and so on, right? These are different data points and we categorize them under data sources, right? And we want to ingest this data so that we could do some transformation, do some querying on top of it. And that is where we do the ingestion. We bring the data all together to do some analysis. So this aspect is data ingestion, right? And why do we want to pre-process process or pre-process data? Data at times needs some cleansing for the transformation to be easier, and it might need some logic that we'll have to write to get the result that we need, right? So that entire, all of these aspects are data processing, and that's exactly what we will deep dive today, right? And finally, to see the insight that we're looking for, we want to be able to retrieve this data and do some visualization on top of it, right? So all of these steps where the data is moving from one stage to another is tied with a pipeline, right? It is a logical step one after the other, which needs to be executed to derive value out of data. And the orchestration and monitoring aspect is key because we want this to happen continuously over a batch time or a real time. And we want to monitor if this is happening right. So all of this at a very high level, this entire process of getting value out of data with these logical steps is what makes data pipeline, right? Moving on. We are going to focus on data transformation, as you've seen in the title of the talk. And what is data transformation? Data transformation is a process of changing the format, structure, or values of your data for analysis, right? We'll go into understanding what is format, structure, and values in the next slide. But when does this data transformation happen? We saw earlier that data is coming in, it's getting ingested, and then there is processing, right? But at which stage do we do transformation? So if you look at the diagram, in the first one, when we talk about data warehouse, the incoming data is cleansed and organized into a single consistent schema before being put into the warehouse. That means the transformation is happening before loading the data into a consistent schema. So that is one place. And this is called ETL, right? E for extract, T for transform, L for load. Before loading the data set for analysis, I'm doing a transformation on the extracted data, right? The one on the right is ELT. ELT comes into picture when we talk about data lakes, where we bring the data in its raw form. We do not do transformation. We bring the data and load the data into data lake as is, and then do transformation based on the needs of the users. So these are the two different stages where you would have heard the transformation happening, and that's what differentiates ETL and ELT. Moving on. We said data transformation is changing these four attributes, right? Structure, format, value. We'll talk about security. What do we mean by structure? So when we talk about data structure, it is how data is stored, right? It can be rows and columns. When we say we're changing the structure, it is either we're renaming the columns or moving or combining the data or modeling the data. And of course, this is true for structured data. For unstructured data, again, it lacks structure, right? So we are talking here about structured data, which is a tabular representation or records in a table, right? When we talk about format, it is how we store the data at disk, which can be any of these formats: CSV, JSON, XLS, Avro, Parquet. And we do some compression so that we reduce the storage that we require for the data. And the type of format really depends on the kind of use case we are solving, because it brings in its own um, processing and storage benefits, right? Values of data. When we say values of data, so far we have not spoken about the actual content of what the data set is about, right? The rows, what are the values, right? Values of data is about filtering those rows and aggregating them and enriching them for certain computations, right? And security is a more advanced topic where you deal with sensitive data. It's important to ensure that over network it is secure by encrypting and decrypting at source and destination during transmit. This can be done at a network level also. And the other aspect is anonymization and masking, where you do not want to reveal PII data, for example, right? These are techniques to do that. And for these also, you're doing some transformation. It is changing its form. So next time you hear the word transformation, you can relate any transformation you think falling into these four categories, right? Moving on. Before this, I'd like to ask our audiences today on data transformation related query. If you've used SQL, right, that's the most simple language to use data transformation for. There's a quick question around that. Please, let's start the poll. All right, so the question is, what issues have you faced while doing transformations via SQL? You have four options: code complexity, testability, documentation, and reusability. It's a multiple choice, so any issue that you faced with the transformation via SQL, please go check them.
If we have some inputs, we can close the poll.
People are still voting. Can you share the results?
Awesome. Yeah. We're seeing that most of us feel code complexity 76% an issue, testability is 53, documentation 24, reusability. So this is the response is telling us that all of us feel that something is wrong with SQL as a language for transformation, right? So that's a good sign that you're in the right place to understand how to avoid that, right? Let me position this new tool that you've come to hear about. It's called DBT, right? DBT stands for Data Build Tool. Let me position this DBT from what you've heard, different languages, different frameworks you've used for data processing. Say SQL, right? SQL is widely adopted, right? Any dev, data analyst, data engineer can use SQL on a structured data and do transformations, right? But what it lacks is readability. It's hard to read an SQL code, right? Especially the big ones, which are solving some use case, and it's quite nested, right? Reusability, right? How often have you seen your code being reused for some other use case, right? Testability, have you heard, right? Like, okay, I've written an SQL code, it's tested, it's there is CI in place for continuous integration on the logic that I've written. Maintainability, like how do you version control your SQL test? These are all the challenges that we also heard our audience say, right? Moving on to Spark, all of you must have heard, if you've heard data, you've heard Spark. It became the default tool after the Hadoop platform came in, right, for big data processing. Spark is easy to use in a way for developers, right, who can write Python and Scala program. But how do I run a Spark job? I need a dedicated data processing cluster. It is distributed. I need to set up and tear down the cluster, manage my resources for optimizing the Spark job, right? And time to market is high, right? I need to do all of this, version my jobs, take care of the optimization, manage the cluster. So there is a lot of learning curve. And why it is so popular? Because it's a unified solution, right? It can integrate with all sources known commonly today, which is data type, messaging queue, API, and different data formats. And it also supports advanced analytics and a lot more, right? I'm not underselling Spark here, but just placing Spark that there is learning curve. And if you want to do simple and fast time to market, right, of your applications around data processing, there is another option that we have, and with less learning curve, right, which is DBT. You can use the same SQL, right, SQL querying, and create modular, reusable, and testable transformations on structured data. Yes, DBT works only on structured data, and it's low time to market because it does not require you to manage all of the things that you've heard about Spark. And data warehouses are powerful today, right? Earlier we thought of MapReduce distributed processing because we had to optimize our resources, but today with cloud services, we have data warehouses that are powerful and can scale with volume, right, and on need basis, right? And what sometimes we miss out is documentation around what we are doing, right? And we don't like doing that much of a documentation. So with transformation, it's even hard. So what DBT helps you is to do documentation while you do transformation, right? So you don't have to think about it later. And it gives you an end-to-end view of what you've done with your data set, right? It'll allow you to do data profiling, which is understanding the nature of the data you're dealing with. And it also takes care of how fresh your data is. So these are many add-on aspects. But the selling point here is with SQL, you can write modular, reusable, testable code, do transformations, and any role can do this, right? Data analyst, dev, and engineer. So this is how we want to place DBT. Moving on. Data transformation using DBT. Yeah, over to you, Ankur.
So we talked about DBT in general, how it's placed. So it's simply the readout of the ETL or the ELT if you want to talk about. And it's just not processing or extracting the data. It'll play the transformation bit in those both roles. And it can be considered as a compiler or a runner, whereas you put in some raw data into it. It gets developed using a query. It does some test and documentation, and it gets deployed in the cloud, and you get an output data set, right? Which can be used in any BI tool. Can be an ML model built out of it, and there is operational analysis you can do it, right? And you see data platforms that get easily supported. There is Snowflake, there's Google BigQuery, there's Azure, and there is Databricks, right? Now, why DBT? So quickly and easily, you can, there is clean transformation that can happen for the data, and there's a ready analysis that can happen. The application development principles of a software engineer just apply there naturally, which is there is modular code, there's version control, there's testability, continuous integration to analyze code, right? There is reusability using the Jinja template, which essentially is just a templating language where the reusability part comes in. Then there is maintenance of documentation, which happens that it automatically generates documentation if you write a few lines of code, and it just does documentation linearly also, where you can see how your data is moving around different stages, which Manisha talked about, right, in the pipeline. There's a simplified refresh that can happen. There's DBT Cloud. It can also use any CI tool which you want to integrate it as CLI, and there's automated tests that come along. Let's do a demonstration of what I was talking about, right? I'll switch back to my machine, and we'll run this command which is mentioned here. So Python version required. Let's check my Python version here. So I'm above the required version, which is 3.7. Let's try and install dbt core. So it says all the requirements are already satisfied since it's already installed on my machine. Let's also run what my dbt version is. So we know what all is there and what version is installed. So we see the installed version is 2.1, but there's also a latest version, which is 1.0 available. And the plugins installed are BigQuery, Snowflake, Redshift, and Postgres, right? Next, there is a dbt utils, which is a package or a pre-packaged Jinja templates, which will act as macros for you, which you can install. And there's also something called dbt profiler, which is also something we'll talk about, which is used to profile the data which we are ingesting and using, right, and staging in different environments. So we tried dbt version, so we know that there is a dbt version installed on our machine. Let's try and create a project. So like any GitHub project, you can just do dbt init and the project name, and it'll initiate a project for you. So let's try dbt init. And I want to name it Jaffa Shop. So let's see what happens with Jaffa Shop. So it successfully creates an project for me and says happy modeling. Let's go inside that project and let's see a list of things that have happened. So there's a README file, there's a data folder, there's a macros folder, there's a snapshot folder, there's an analysis folder, dbt project file, models file, and test file. I'm going to try and open this project in IntelliJ. Right. So you see a project structure which has analysis, data, macros, models, snapshots, and tests, right? Let's talk about first the dbt profiles file, right? So project file has a name to this project which you can edit, the project which you're creating, a version to it, the configuration version which you're using. Profile is something we'll cover just next after this. So profile is something which can be defined on the basis of the environment you're using or the different data platforms which I suggested you can connect to, which will have different profiles you'll connect to. Or if you're using the same one, still you need to differentiate the different environments when you go live with your data product, right? These are the run places where the dbt runner can or compiler can find the models, the analysis, the test, the data, the macros, and the snapshots for the same. Now let's talk about models. Anything in dbt would be SQL, and when you write an SQL file, it creates a model. Model could be a view, a table, or an incremental, which is again a table in any data platform you're creating. Now we're talking about a structured data, so it will be a view, table, or an incremental, which is also a table. So you can configure here for the particular project structure which is there, right? There is in models, there is example. So inside example, whatever is my material, let's say whatever's the SQL file inside it, it becomes a view, right? And inside the SQL file, if I'm rewriting the materialization at is table, it'll overwrite it and create a table out of it. Now, how this works is that you have to just write a select query, and whatever select query you've written down, that model will be created. Right? That happens for the second one also. Now, here is something interesting, which is the reusability part of it. We just created a select query, which was in my first dbt model, right? In the second dbt model, I want to write a select query just to select the first particular item of that table with ID 1. So I'm using a ref macro, which is just a way to reuse using the Jinja template. My model which I've either already exist or I'm just creating, right? So I can refer this instead of writing another query inside it and use the existing table that was created. Now let's talk about the next point, which was I had to come to, which is profile, right? Let's view my profile. Now this profile is a dummy profile because I don't want to share my Snowflake credentials with you. So we can name it. So it's currently called Snowflake operations. It'll have a target. What output my DBT needs to connect to, I'm configuring over here, which is my type is Snowflake. So I'm connecting to a data platform, which is Snowflake. This the Snowflake account ID, which I'm connecting to. The username, the password I'm using to connect, the role with which DBT needs to run all these models, which will be transformed. So the transformations, the database it is going to connect to, the warehouse it is going to connect to, the schema in which my transformations would be created, the number of threads that need to be run, right? I could have been able to run this DBT debug command, but since I've put in the dummy username and password, so it'll fail for me. But if you put in the right credentials, it'll work and it'll tell you whether the DBT is easily able to connect with your Snowflake in our case. Right? The code consists of models, the project.yaml, and the DBT projects.yaml, which I talked about, right? Projects.yaml is something where you can actually configure where your YAMLs would be there, your database connection would be there, the schema would be there, the roles could be there. So you could just configure all the things which I said according to also to the basis of the different platforms you're using. Okay, let's actually look at the piece of code which is going to create all the things. I'm going to explain this using a use case. The use case is that there is a Jaffa shop which we just created, right? Imagine it was a local retail store which used to do a lot of customers. It had the local customers used to come there and love being there. Now it's been taken over by a giant retail chain. The retail chain name is the big store plaza. Let's name that, right? But they don't want to lose the customer base of the local store, Jaffa shop. And the big store plaza already has Snowflake warehouse available to them where they already store their data, and that data analyst creates a lot of proportional offers. So the idea behind over here is that whatever data is the customer data is available in Java Shop in form of Excels can be ingested into Snowflake, and using the same data analytics tool which they are using, they can push some promotional campaigns, right, for the Java Shop. So I'll give you a glimpse of this in Snowflake also, but let's understand what our source tables are. So there is a customer table which has ID, the first name, the last name, the email. There's order table which corresponds to a user ID from the customers table. It has its own ID, the order date, the status. There's the payments table which has ID, order ID, payments method, and amount, right? So I think using all these information, we can actually create a campaign, right? Now let's have a look at what these source tables look in Snowflake. So I have a Snowflake connection in place, and we had them these into CSV files in an S3, and we created source tables out of it in a schema called raw, right? Which was created using a first name, last name, ID, and the same structure which I talked about. So all these tables are actually available to us in Snowflake, and we could query them and preview the 100 rows which are available. So the customer table looks like there is an ID and the first name which is there, right? The order tables look like that there is the order ID, the user ID, the order date, status, and the time when it got loaded. And the payments table has the order ID, the payments method, the status of the payment, how the payment got made, was it successful or not, the amount of the payment, when was the payment made, and when was it ingested inside Snowflake, right? All that information is there. So we could create a transformation that will give us a good enough output to do that. Now let's move to the actual transformation, which I can show you. So this is the expected output which we are looking for. Let's preview that. Okay, for some reason this is not getting previewed here. Let's show you in Snowflake itself. Right, so this is the output which we are looking for, that we need a customer ID, we need a first name, last name, the first order date, the most recent order made by the customer, the number of orders, and lifetime value of that order. So we're looking at how who's the most valuable customer for us, right? So maybe there is this person who's done 65 orders with us, right? 65 is the dollars of transactions with us for 3 orders, and there's someone who's done 2 with 33 values. So this, using this, we could create a campaign. So we see over here, this is the lineage which I was talking about, that we have a customers, the order, and the payments, and each of them schemas have a table which is stage customers. So we could go to staging and we could see that there is stage customers, right? There is stage orders, and there is a stage payment also. Let's go to Stripe. Let's go. We have a stage payment also. Now, first we need to do is what we need. We need to configure sources in dbt. So inside the Jaffa shop, there is a database which is raw, which is exactly what we saw here, that inside Jaffa shop, inside raw, there is a customers and an order table, right? So that's what I'm trying to tell, that there is a customers and an order table. We'll come to the test bit, but this is a basic understanding that there will be an ID in both of them, right? Similarly, I'm creating a source for the payments table also. And using those sources, I'm creating these models, which is stage customer. Now the customer again has the same thing which we talked about, the customer ID, the first name, the last name, which got created. Similarly, the orders has the order ID, the customer ID, and the order date which got created. Same happens with payments, which have payment ID, order ID, the payment method, the status, the amount which we did by 100 since we're converting to dollars, or you could say rupees, and then we're just changing the name of this. So these are all different types of transformation that can happen to a source, right? What we're doing then, that we're creating a correlation between the orders and the payments, since we saw that in the source tables, right? There is a correlation between the order and the order ID in the payments. And there's no correlation between the payments and the customers, but there's order and customers relationship. So we are selecting orders from orders, payments from payments, and we picking the successful payments out of that. And from final, we are bringing in, so there we've created something called final, which has the order ID, the customer ID, the order date, and the amount, where the consolidated amount of a customer where the status was successful. And then we have the final transformation, which is talking about the customer table, the fact of the orders table, and we're slightly renaming the customers and the orders, where customer first order is called minimum order is called the first order, the maximum order is order date is called the most recent one, the total count is there, and the life value, like how much they have purchased from us. And finally, we have the final view, which we saw in Snowflake. which was that there is customer ID, first name, last name. So I could just do a command called dbt run, and this would create all these tables which I was talking about. So the stage tables are created, then the next table which it got created was facts, and so similarly you can see in the lineage. Now let's try and refresh, and you'll see that it got created. Hmm. So you see this was just created, right? That is the target database which was there. And if we preview this now, this was one of the cool features I wanted to show you. You could preview the data. It did not get preview at that point in time because most probably I dropped that schema or the database from there. But now it's visible, and you could see exactly what happens with each query without even committing anything to Snowflake, right? So this is one big advantage that comes along. Next, we'll talk about data transformation tests. So testing the same thing which we talked about. I'll ask Amini to put up a poll for us. Which talks about that if we talk about testing,
it matches with the source schema, right? There is compliance and all the checks, all the valid checks that we need to take care of based on the row count or any such rules is validated, right? Whereas in ELT, we ensure that data is complete, like because there is no transformation happening and there is direct loading that happens. First, transformation happens later. We just ensure that data is complete, meaning that all the rows from the source have reached the persistence layer, the storage layer, and on top of that, all the transformation that we apply, we start validating and verifying them, and they'll be applied in series, like we saw in earlier example. There is staging layer, then there is fact layer, and then there is the final data set, right? So these are the series of transformation, and in ELT process, we verify these series of transformations, right? Moving on. Okay, how to go about doing this data transformation testing? Like any software application testing, being involved in the earlier stages of defining the requirements and working together with uh, the business analysts, the users, and the developers is key here, because data transformations change based on requirements, right? So if I just define on how do we want to do this, it is detect the source data issues early, right? The inconsistencies early, because the later we do this, we have to fix it in multiple places. So and this can be, the thought process can be broken down into 5. One is identify the business requirement, why we are building this transformation, what is the business flow, what are the client expectations, right? Then validate the data sources. If I want to cater to these business requirement, what are my sources? What is the nature of these sources? Is it structured data? Does it have a table? What is the refresh rate of this data set? What is the type of data coming in? Are there some quality issues with data, etc., right? Try to understand the sources better. Then design the test cases that map the required analytic output, right? And design and document them and share it with your developers, right? Then when they look at these test cases, they'll be able to better apply the transformation logic, right? That needs to be, that meets the requirement that we want to build, right? So there is alignment on data threshold, the validity of the transformation that they've built, the schema is matching with the target data, and so on, right? Apply the transformation logic. And then finally load the data in the required final table, which is used for the visualization or further downline analytic use cases. And here we want to ensure that data on loading is also not missed. So the transformation that we do generates, like if we do an aggregation, we expect the row count to be lesser than the raw data, right? So we can apply such checks, which comes from our understanding of data, right? So key here is understand the requirements and the data expectation of the transformation beforehand, and be involved in the process and define as the transformation changes. So this is how the data it's not a one time definition, but it's an evolving process. Moving on. How does DBT come to play with testing, right? We have told DBT that we have spoken about how we write these models, right? And we've seen an example in DBT Cloud where Ankur showed us that it's just a select
talking about SQL is that we want to write fail queries. When we say we want to check on live data, which is streaming, or even while we are writing any unit data test or any integration between two different models that are going on, you cannot write successful tests, right? When it comes to the data, it's not KBs, it's not MBs. You will have gigabytes, terabytes, petabytes, and way more going on. That was one reason why people were scaring away from SQL, right? Because you could not test it. The major part which we want to test is when it fails. So you're going to write more failure select statements, because the which is valid data will pass through, right? But we want to find out which are the anomalies and write a test for them. There'll be two types. You can write a select query, which will be again just checking whether it's failing or not. And there is something called generic test, which will be very generic to the different parameters that are part of those queries. We'll see that in examples. Let's see the demonstration, right? So what I'll start with is that inside the test folder, which we saw also over here, that there is a test folder and it was empty. It was created when we initialized the repository. Let's write this SQL statement and understand. So I'm going to remove this and I'm going to ask you, and I'm going to read out the scenario, and I'm going to ask you, if you're in chat, please write down what the select query you think would be for that. Right? Which is
Ankur, sorry to interrupt. Can you please zoom in a little bit?
okay, let's try that. It's still in the browser, so
Yeah.
I hope it's visible now. So refunds have a negative amount, right? They cannot have a negative amount, right? So that the total value. So this is the negative scenario which we're writing now. That refunds have a negative amount, so that the total amount should have been greater than equal to 0, and therefore the records whichever come in will not be true. It's a failure scenario. So in chat, do you want to? Does anyone want to write that query and see if that works out? Maybe I can write along. So we'll write select for sure. And then we'll also talk about order ID, which just for sure, right? Let me write the spelling correct, right? And then we're gonna do a sum total of the amount. Let's say this is the total amount. Right. And since we have already created this table, so we'll use the reference template over here from Jinja, which says ref. And we know we're talking about the payments table because it's an amount. Right. It's the payments table. And we group it by 1, since we need the sum of all this. And here comes the actual query, which we are going to validate, right? Having not total amount, which is greater than equal to 0. So we already had that statement over there at the top. So it's just the same thing which I'm writing. So we can just run this query using a command called dbt tests. It'll show you more tests because I've already written down some generic tests, but this is the actual test which we wrote down, right? The name of the test was assert positive total for payments, and you see this test got run and it got failed. So what it does is essentially inside it runs for the failure count, and if it's not equal to 0, it gives a warning. Otherwise, it also gives an error. And this is the documentation of actual query which was there, and this query actually internally got run. For the result, if the count was 0, it got a pass. If the result would have been more than 0, it would have passed. Right? Now let's have a look at the generic test. We'll start with the source test, which we left earlier. So in the source file when we were staging, the customer table should have a primary key, right? Which we saw, which is there should be an ID which will be unique and primary. So it's a primary key, and the order ID again would be unique and not null, right? So that's the attribute of the primary key. And we also saw that there is the ELT load time where we can actually validate the freshness of the data, right? Let's say my worst case scenario is that I cannot accept the data which is more than 24 hours old, right? But I'm saying give me a warning if it's even 12 hours old. So I get alert and I can tell people that, hey, data is not getting refreshed. There's something wrong with the data pipeline, right? Similarly, but if it's 24 hours old, I don't want the transformation to go any further, because my visualization might break down completely, because it might be just expecting today's data, but the today's data is not available. It's all yesterday's data. So you'll see a blank dashboard, which makes no sense, right? Similarly, let's talk about the test for this particular SQL query. Right. So it'll be again in the YAML file where we're defining this model, which is the stage model. And we are, after converting that into a stage table, we are expecting that it should still be primary, right? The order should also be primary. And this is something interesting test, which is already existing as part of DBT, which is the accepted value. We know that in the order status, some expected values are there. The order status could be either completed, shipped, returned, placed, or return pending, right? And we also know from the source tables which we saw that the customer has a relationship with the order table. So inside order table, there is a customer ID, which is a foreign key or the stage customer table. So this relationship macro, what is doing is referring to this same table which we were using, and checks whether that field customer ID exists or not and is the same or not, right? So these are some generic tests that will exist. Let's come back to the presentation. And this is one extra attribute which I was talking about. So it's a plugin which you'll or a package which you need to install. It's called dbt profiler, which will implement more macros. So far we've just seen the ref or the source macro. There's another macro which I just created as an example. So this is how the not null macro would look like. That inside there'll be a test. Since it's a test macro of not null, it'll take the model name, the column name, and select star the model and check whether everything for that column is null or not. Since it's a test, it's again a negative statement, right? Now let's look back at what we were looking at, the profiler. So I've already installed the package for us, right? And this profiler will give us the name, the data type of the columns, the null proportions, the distinct proportions, the distinct values that are there, the distinct count, the unique, the maximum, the minimum, average, the standard deviation of the total population of columns, the sample, and the profile. When was it profiled, right? So let's run that statement here. So the statement, what it is doing, it's running the operation and printing the schema and the relation for the customer tables. Let's hit enter. Still processing. And here we have a summary, right? This summary, let's zoom in for you, which says that for version 2 you're running, for this particular model you're running, there's the column, for each column it's going to show. So for customer ID, it shows all the metadata, which I talked about. So the average number in the customer ID is 50, which essentially makes no sense because it's the ID. But the first name, it doesn't have any, minimum maximum because it's a string. Similarly for last name, but it shows that there are total 100 rows. What's the proportion of that, right? So this is, you can do this for all the tables possible, and this could be used as a profiler also. I'll ask Manisha to talk about quality gates.
Sure. Meanwhile, there's a question, Ankur, if you can take that. Okay, quality gates. Move on to the next slide. All right, different testing levels, right? It's important to understand when we are testing data, what are the different levels at which we want to put the safety nets, right? If you talk about product validation, it's in the final stage where we have already done the transformation, the application is live, and application is live, and we want to validate what we build, the final product matches with the actual source data, right? This is more of a manual testing where we want to check that there is no faulty logic or failed loads with the data sets, with the data transformation that we are testing, right? This is what happens towards the end. With data quality testing, we want to more focus on the data quality itself. The when we say data transformation, we learned about structure, values, format, etc. of the data, right? In data quality, we want to check exactly that. If I say that this data is of good quality, I'll define certain parameters, like it should have a it should not have nulls, for example. It should match the pattern, that pattern of row that I'm looking for, and so on, right? So if we can define quality attributes for a data set, data quality, source to target test data testing is process of ensuring that the projected data is added to the target system without loss or truncation. This is pretty straightforward, that what you have in source, you've moved it to target successfully. Metadata testing is more on what defines data, right? Like data has a type, data type, length, constraints, right? And there is application. There could be some constraints coming from the use case itself, right? So metadata testing is testing more about the metadata of the data. And data integration testing is when we build the final use case with integrating multiple sources and different layers of transformations, right? We want to test the end-to-end integration. So in this process, we confirm that all the data sources have been loaded to the target warehouse correctly post transformation, and check the threshold levels, right? And data transformation testing is focused on the unit of transformation itself. In our case, when we talk about DBT, our unit is a model, right? So when we saw the tests in the past, it was testing that particular model. When we're talking about customer, we don't want null records in customer for an ID. We don't know a customer with null ID, right? And a specific rule on a payment, right? It's on a payment model, and so on. So we are testing model, and we're testing, like, if this is transformed, does it give the right result, right? So testing the unit of transformation, which is basically running the queries for each of the transformed records and ensuring that it matches the requirements. So these are the different testing levels that's possible with data. Moving on. What are the challenges? Why we don't see these practices happening in our real project, right? And it's hard to identify them also, right? On what testing makes sense where, right? Now that we have understood that quality gate, if you want to apply those, identifying challenges early in the process can prevent bottlenecks and delays, right? And creating source to target mapping document, establishing clear business requirement from the start is essential. And there could be frequent changes, right? That requires the quality analyst or testers to change the logic in the scripts, and it can significantly slow the process. That means the analytic requirements can change and the transformation can change. So keeping up with them is one challenge. Also, what is the most important thing that we need for testing is data itself. So at times you don't get access to the source data. The data might not be of good quality. It might be lost or corrupted during migration or during ingestion. Underestimating the requirement, not really understanding the source and thinking it's an easy task to just validate, but there's a lot of hidden issues with the source data. So underestimating the requirements, dealing with duplicates or incomplete data. And at times, transformation need to work on large historical data, and for somebody to really validate that entire data set is needed. So working on large volume data for testing is also tricky, right? And testing environments need to be stable and need to be updated with the latest libraries or environments for this to happen, right? So these are the different challenges that we've seen and in doing data transformation testing. Moving on. All right. So far we've covered. We started with introducing data pipeline, and we said in this we will talk about transformation. We've done that. We've covered DBT. Now we want to circle back and say, let's look at the data pipeline in little more detail, right? So let's go to the next slide. Okay. So data pipeline stages. Initially, we just saw data sources, ingestion, processing, and retrieval and visualization, right? But what are these? Let's look at a little with examples. So data sources are sources where the data comes from. It could be a file, it could be a database, a Kafka topic, any messaging to an API. Data ingestion is the process of moving the data from source to the target site for further analysis. Persistence is where you store the data so that you can do the analytics or query on top of that. That's why the storage needs to be massive, right? It should be easily accessible and flexible to our requirements, right? And data processing is our transformations, process of changing the structure, format, structure, and values of data, right? And data modeling is how you want to maintain this relationship between structured data, which is tables, into your target warehouse. When you bring this raw data in, what is the modeling technique you want to apply? How do you want to keep the relationship? Some of the examples could be dimensional modeling or data vault modeling, right? Data retrieval and visualization. So all these are where data analysts or engineers are comfortable with, but for real business users, it's hard to deal with all of these data modeling related terminologies, right? And query layer is not very friendly. So retrieval of information in a format like a visualization or a KPI that could be understood by the business very easily is where data retrieval and visualization comes in. And all of this, like we spoke about this earlier, orchestration is important, that it needs to keep acting on the moving data, right? The live data, right? And it needs to be monitored, right? Because there are lot many moving pieces here. Data is changing. There are so many stages, and one it's a cascading thing, right? One stage output of one is an input to another. So monitoring is essential from both data and infrastructure point of view. So these are the different data pipeline stages. How do we do data pipelining for DBT, right? DBT is an open source Python package, which gives us the ability to define transformation. But how do we orchestrate it? How do we productionize it for our projects, right? Let's go to the next slide. There are multiple ways to do this, right? DBT Cloud is an enterprise version of doing this, where it allows you to define jobs, which define these DBT run, DBT test stages for your models, right? You can schedule that based on your requirement. You can define when it needs to run, what event should trigger the run of this, right? As in for freshness, if data is not fresh, let me not trigger my transformation, right? What else do we need? We want to run tests, right? For our continuous integration. So there are many when we think about end-to-end deployment, we want to keep in both the continuous integration and continuous deployment in mind, right? Let's so what Ankur is showing us here on the screen is DBT Cloud interface, which you have seen earlier. We will quickly open the DBT pipeline and we will see the example that Ankur showed us and go through the pipeline steps, right, one by one. Now, where is this, all of this code written for these models? It is hosted on GitHub, right? And we will use DBT to integrate with any of our code repositories, like GitHub, for example, and then pull in that code. That is first step, right, of any deployment, right? Get the latest version of your model configuration into your pipeline. All right, just a second. Let me share my screen.
We got it.
We got it. All right, good. What you see here is the deployment environment definition. What you need to, what all do you think you need for deploying a DBT code? You need code. You need where this transformation needs to run, right? The warehouse. So you configure this in the DBT in the environment section. Once you've set up the environment that this is where I have to pick the code, and this is my target data warehouse, we will define a DBT job. Let's look at the definition. Let's go to settings and go to edit. Right. Here we are saying, let's give a name. We are saying vodka, and we are saying deploy. It's of type deployment. We are using a DBT version which is v1.0, and we could use any branch for deployment. Here we are taking the main branch by default. Custom branch is off, and we'll make a connection to our Snowflake database. We'll give these credentials and deployment credentials. With deployment credentials, we're giving credentials of DBT Cloud, right? So scroll down, go to edit and scroll down. Okay. Yeah, settings, edit. All right. Under jobs, let's go to jobs. Yeah. Settings, yeah. Edit. All right, it's all visible here. So we are saying that we've defined the environment. Now we want to define the job. So we will say what environment is defined in the first section. The second is the execution setting, right? Here we want to say that we want to generate docs. We've not seen the documentation part of DBT, but say in our pipeline, we can just enable this as on, and we will see when the pipeline runs, it will generate a documentation. Run source freshness. We can tell DBT to keep validating the freshness of the source. And it should trigger our models only when new data comes in, right? So that's the parameter. The next is what commands do I want to run? In the demos, you would have seen DBT run and DBT test, right? What DBT run does, it compiles the ref, all the Jinja templating, right? It replaces it with actual query. That means ref will start pointing to your target database, target table, and so on. That is the compile step. When DBT run is executed, it runs that compiled SQL onto the target warehouse, and DBT test understands all of the test definitions we have done for each of the models and runs it against the warehouse after the model is built. So these are the two steps: run and build your models, and then test the output, right? And if you go down, there are options to schedule this. I want to refresh my for in our use case, we said we will profile a customer to see which is a more valuable customer. Say I want this information every hour. I want to say send new campaigns every hour, which we shouldn't because customer will get annoyed. But just for example, we can say we can set the cron or set the schedule here, saying this is a refresh. This is when I want my models to be refreshed, right? And if you want to additionally integrate with other tools like Google chat room or any messaging, you could use webhooks, and you can use even DBT APIs if you want to build a layer on top of it for monitoring and see what's happening, right? There's an API integration as well. All right, let's look at one job that we have already run, and we'll look at the stages, right, at a very high level. So clone the Git repository, create a profile from connection Snowflake. We had a question in chat on how do we define the warehouse, right? This is the profile.yaml that we've seen earlier. This is where we are telling DBT that use this profile, which has the warehouse that it needs to use for compute. And it knows now what is the target warehouse and the compute it needs to use. Next, install all the dependencies that you need. You want to profile your data. There are many open source support libraries for DBT. If you install DBT Profiler, you'll be able to do profiling, for example. So in this step, install all the dependencies that you need for your project. This is the command dpt deps. Then you do dbt run, which in this example, you see stage customer orders payments, fact orders, and dim customers. They've all run and they've been successfully modeled. And next is dbt test. If we'll open dbt test, we'll see that these are all the tests we've defined, the generic test and specific test, right? We have done null checks on some, we have defined a specific test on positive total for amount and so on. All of them, you see the statistics of the time taken and the successful run of those tests. And finally is the interesting bit, which is dbt docs generate, which we have not seen so far. So let's open the documentation. We have asked dbt to generate documentation of what has happened in this run. So what we want to see is what did dbt do with this pipeline. It will show you that these are the models that it has built. This model has these many columns. This is the data type of that, right? And if we take orders, for example, it says, yeah. In the column section, we can also give description, right? Order ID is primary key for orders, right? And here there is a test also along with the column, that we have a foreign key test, that every column in customer table, the customer ID should have an order ID, right? So that foreign key relationship test is also documented here. And if you want to further detail out the documentation, saying, okay, we had different types of order status. Like we want to document all of that, right? Is that possible? Yes, you can have a separate documentation file and link it to your column, right? And you will be able to see all of this, right? And if you want to see the tests, if you can scroll down towards the end, you see that these, if you click on tests, these are all the tests for stage orders that have run. And it depends on orders. That means any of the child or any of the parent models that you've used will start reflecting here. And you'll also see the source version and the compiled version of your query. This is exactly what happens in dbt compile. It is translating the ref, which we see in source, right? Source Apple shop orders is mapped to raw Apple shop orders, right? That's the compiled version before it executes. And there's a lot more here. You could, when you try this, you can explore that there's a lot more information in the documentation. And where is all this defined? It is defined in the code, in the YAML file. Ankur, if you could quickly bring up the YAML. Any one, maybe orders. We've defined it in the YAML configuration. So we've seen a dbt project structure has YAML files and SQL files. YAML files is mainly used for this, for you to define your models declaratively and add tests, add documentations, and so on, right? Right? Yeah, here we have written description, right? Line number 22. And it says doc. It is pointing to a macro called as doc, and it is passing a variable called as order status. And we have a .md file, which has order status in the doc's first macro tag and an end macro tag. And between this is the entire definition, which we saw in our dbt cloud documentation section, right? And with every click, you were seeing a lineage below, right? It is showing how these models are linked. When I build the final model with this one view, I'm able to see and correlate what are the relationship that exists with my data, right? Which is not out of the box anywhere. If we use any transformation, we'll have to look at a separate data catalog, separate data lineage UI to do this, right? So there are many cool features for data analysts and engineers to come explore DBT because of these many add-ons. And there's a good support for different libraries, different open source libraries for DBT. And yeah, all right. What do we have next in our?
We just ran this job and
Yeah.
you could actually see the output of this pipeline. So it was maybe first this. And so doing that refresh. 37 minutes ago. So this was the output of the job which we just saw, right? So it got run 9 hours ago. This one. This was what we were looking at. Come back.
There are other options when we talk about how do we do data testing, and these are other libraries that you can explore. AWS DQ, Great Expectations, Perfect.io is an end-to-end workflow, plus it enables you to write Python-based testing. Datafold allows you to compare data sets and write tests. So if you want to build a solid data transformation setup, right, with testing, CI, documentation, lineage, all in place, DBT fits perfectly there. But these are additional things where you're only looking for specific things. Like I have everything in place, I'm only looking for testing. I have everything in place, I'm only looking for like flow-based testing. You can go for perfect.io. So there is no direct comparison to DBT as yet, because it is unique in its own way, but these libraries do some aspects of it, right? So we want you to look into this if you have additional interest in this topic. To the last slide, maybe. Quick recap, we've covered these so far. We've done transformation using DBT, testing, quality gates, what is a data pipeline, and how do we do this data pipelining on DBT Cloud. Awesome. Hope you found this interesting and useful. Over to Soumya.
Hey, so do take some time out to fill the feedback forms. Tarun, you have shared. I see Akanksha has also shared the link.
So now